show that for all positive integers a, b, and m, that 3a plus b times 3b plus a is never equal to 2 to the power of m. In other words, is never equal to a power of 2. So first, let's assume 36 times a plus b times 36b plus a is equal to the power of 2. Well, in that case, since 2 is the only prime factor of this, that means that 36a plus b and 36b plus a are also powers of 2. So let's let 36a plus b be equal to 2 to the power of x, which is also equal to r. Let's also let 36b plus a be equal to 2 to the power of y, which is equal to s. So first, let's consider r over s. So r over s is equal to 2 to the power of x over 2 to the power of y, which is also equal to 2 to the power of x minus y. So now let's use limits to solve for this value. So first, the limit as a approaches infinity of r over s, or 36a plus b over 36b plus a, will be equal to 36. Now also, the limit as a approaches 0 will be equal to 0 plus b over 36b plus a, or b over 36b, which is also equal to 1 over 36. And so we know that 1 over 36 is lesser than or equal to this, which is lesser than or equal to 36. Now the only thing that I'm looking for here is 1 over 36 is lesser than or equal to 2 to the power of x minus y is lesser than or equal to 36. Now notice that 6 is the least power of 2 that is greater than or equal to 36. Now we can set some pretty loose boundaries here. So then you could say that negative 6 is lesser than the log 2 of 2 to the power of x minus y, or x minus y is lesser than 6. So now let's move this to the top, and then I'm going to continue solving. So already we know that 2 to the power of x minus 2 to the power of y is equal to r minus s. But also remember that 2 to the power of 2x minus 2 to the power of 2y is equal to r squared minus s squared. And so 4 to the power of x minus 4 to the power of y will be equal to r squared minus s squared. So 4 to the power of x times 4 to the power of y, if we factor out a 4 to the power of y, we get 4 to the power of y times 4 to the power of x minus y minus 1 is equal to r squared minus s squared. So now let's solve for r squared minus s squared. R squared is equal to 1296, or 36 squared, a squared plus 72ab plus b squared. Now s squared is equal to 1296b squared plus 72ab plus a squared. So now r squared minus s squared is equal to 1295 times a squared minus b squared. And so this is equal to 1295 a squared minus b squared. Now, 1295 is equal to 36 squared minus 1. So we can use a difference of squares to expand this. And so this is equal to 35 times 37 times a squared minus b squared. Additionally, note that 35 is equal to 5 times 7, and then multiplying by 37 times a squared minus b squared gives us 37 times a squared minus b squared. Now notice that all of these factors are odd. Now notice that 3 of these factors are odd, meaning that one of these must contribute an odd factor. And since 4 to the power of y is even for all integers y, 4 to the power of x minus y minus 1 must be equal to 35 times 37. And therefore, 4 to the power of x minus y minus 1 must contain all of the odd factors of the right-hand side. And so the important thing here is to notice that 4 to the power of x minus y minus 1 must contain a factor of 37. And so therefore, taking modulo 37 on both sides, we get that 4 to the power of x minus y minus 1 is congruent to 0 mod 37. And so 4 to the power of x minus y is congruent to 1 mod 37. So now let's move this over here and then continue solving. Now let's set z to be equal to x minus y. So now let's try powers of 4 mod 37. So if z is equal to 1, we have 4, 2, 16. So for 3, we have 27. For 4, we have 35. For 5, we have 25. For 6, we have 26. For 7, we have 30. For 8, we have 9. And for 9, we have 36, which is also congruent to negative 1. And so squaring this, we get that 18 is the smallest power, such that 4 to the power of x minus y is congruent to 1 mod 37. Now for a reason that I don't understand, the official APMO solution chooses 9 as the smallest x minus y, although according to this, it seems more like 18 should be the correct answer. However, it doesn't really matter as we reach the same conclusion anyways. And so the least possible value of z, or the least possible value of x minus y, is equal to 18. Now, notice earlier that we said that negative 6 is lesser than x minus y is lesser than positive 6. And since 18 is not within this range, we have then reached a contradiction except for one last case. The last case being that x minus y is equal to 0, or x is equal to y. So if x is equal to y, that means that 36a plus b is equal to 36b plus a. That means that 35a is equal to 35b, and a is equal to b. So if x is equal to y, that means that a is equal to b. Now if a is equal to b, then we get 37 times a, 37 times a, or 37 times b, 37 times b. Either way, it's pretty obvious to see that this is never equal to a power of 2. And so, x is not equal to y. Therefore, x minus y is greater than 18, and so we have reached a contradiction. And therefore, 36a plus b times 36b plus a cannot be equal to a power of 2, and so we are done. Now, really quickly, just as a little bit of a bonus, I'm going to show you a much faster solution. So we do the same thing to start. Assume that 36a plus b times 36b plus a is equal to a power of 2. But notice that since a and b must be positive integers, that means that 36a plus b and 36b plus a must be greater than or equal to 37, since a and b must be greater than or equal to 1. So that means that this must be greater than or equal to 2 to the power of 5. Now it's pretty easy to tell that 2 to the power of n is congruent to 0 mod 4, as long as n is greater than or equal to 2 and n is a positive integer. And so that means that 36a plus b must also be congruent to 0 mod 4, since 5 is greater than 2, and 36a plus b is greater than or equal to 2 to the power of 5. So now 36 is a multiple of 4, so all we're left with is b is congruent to 0 mod 4, and that means that b is a multiple of 4. Similarly, we can do the same thing for 36b plus a to get that a is also congruent to 0 mod 4, and so a is also a multiple of 4. And so now, let's set pq to be a solution to this equation above. Now, without loss of generality, let's set p is lesser than q. As we've proven earlier, they cannot be equal. Now, under the assumption that pq is the solution to this equation, let's assume that p is minimal. But we also know that p and q are divisible by 4, and so 36p plus q times 36q plus p must come in the form 4 to the power of m for some positive integer m. Now remember that the square root of 4 to the power of m is equal to 2 to the power of m, and so taking p over 2 and q over 2 must also be a solution. So p over 2 and q is also a solution. And remember that p over 2 is always a positive integer since p is divisible by 4. And so now because we have reached a contradiction here, we have also reached a contradiction here. And so 36a plus b times 36b plus a cannot be a power of 2. And so we have proven this much faster than the first time. Alright, thanks for watching. Hopefully you've enjoyed, and hopefully I'll see you next time.